Welcome to Cambridge Forum, discussing after Copenhagen, looking for real solutions to global climate change, with James Hansen. I'm Tim Weiskell, a member of the Forum's board. In December 2009, Copenhagen talks on global climate change failed to produce a new international accord, and our speaker, James Hansen, is not wasting any time bemoaning that failure. In fact, he didn't go to Copenhagen, and he thought it was probably going to fail. Rather than, as it were, crying about that, he has seized upon the opportunity to renew and expand the discussion of climate change and look for new ideas that will lead to real solutions to this global problem. What might the road forward look like? What should scientists turn their attention to after Copenhagen? What should citizens be doing? Dr. James Hansen first brought global warming to the world's attention in the 1980s, when he was the first to testify at great length before Congress. Since then, he has pursued a distinguished career in research, measuring current climate trends and projecting humankind's potential impacts on climate in a series of robust models. He's an adjunct professor at the Department of Earth and Environmental Sciences at Columbia University and at Columbia's Earth Institute, and director of the NASA Goddard Institute for Space Studies. And he has continued to bring the problem of global climate change to a broad public audience, appearing on 60 Minutes, ABC News Tonight, Anderson Cooper, Charlie Rose, and NPR. He's been interviewed in the New York Times and profiled in the New Yorker, and has written for the Boston Globe, The Nation, the New York Review of Books, and Scientific American. After literally writing hundreds of professional and sometimes popular articles, Mr. Hansen has just published his first book. Now, this is actually quite interesting to academics because we usually rail against the world on a regular basis, saying the trouble with the world out there is they haven't yet read the book that I haven't yet written. Well, the fact is, he wrote the book now. So we can all get a copy and get it signed afterwards. But in fact, he's gone beyond the confines of the scientific research and addressed in this particular book, as you can tell from the title, Storms of My Grandchildren, directly the problem of intergenerational ethical responsibility. Welcome to Cambridge Forum, James Hansen.
Thanks very much for this opportunity to discuss this problem, this issue, this matter, which doesn't need to be a problem, but we have to discuss it as one, because if we stay on the track that we're on, it's going to be a big problem for our children and our grandchildren. I made, I think, a nice PowerPoint presentation on the train on the way up here, and then when I arrived, I realized there's no facility for PowerPoints. So I'm going to look, but I think my charts will actually be preserved in the video form of the record of this discussion. And I'm going to refer to some of the charts in a way which I can do orally. I was asked to discuss what we should do now after Copenhagen, after the stalemate that was reached there, and what is the real solution? And I have clear opinion about that, as I discuss in my book, so I would like to bring that to you. The first chart that I show is the temperature of the Earth over the last 65 million years, because people often say, well, the climate has often been much different than it is now, so why are we so concerned about human impact on climate? And in fact, if you look at the temperature curve for the last 65 million years, well, at the beginning of that period, which is called the Cenozoic era, the planet was so warm there was no ice on the planet. There were alligators in Alaska. their sea level was 75 meters higher, or almost 250 feet higher. And we know why. We know that the atmospheric composition at that time had more than 1,000 parts per million of carbon dioxide. Well, now it's 387 parts per million. And we know why it changed, because on long time scales, the amount of carbon dioxide in the atmosphere is determined by the balance between the source. The natural source of carbon dioxide is volcanoes, which are associated with continental drift. And that varies with time, depending upon where the continents are, how they're moving. The natural sink is the weathering process, which transports sediments to the ocean and deposits carbonate sediments on the ocean floor, in the process taking CO2 out of the atmosphere. Well, 65 million years ago, India was still south of the equator, and it was moving north rapidly. And 50 million years ago, it collided with Asia and began to push up the Himalaya mountains and the Tibetan plateau. And while it was going through the ocean, it was plowing through this ocean that had long been the depot center for the major rivers of the world. So there was a lot of carbonate sediments, and it was spewing CO2 into the atmosphere. And then once it crashed into Asia, then that source diminished, and the sink associated with weathering was increased because of the Himalaya mountains and the Tibetan plateau. So the amount of CO2 in the atmosphere gradually declined over the last 50 million years, and the planet cooled off over that period. 34 million years ago, it became cool enough that ice began to form on Antarctica. And eventually, it got cool enough that we began to have ice sheet on Greenland, and at some times on North America and Asia. Those changes, the imbalance between the source and sink, the natural source and sink of carbon dioxide, is of the order of 1/10,000th of a part per million per year. And in a million years, such an imbalance is 100 ppm of CO2, which is a big change and can cause a large climate change. But note that the rate that humans are now causing CO2 to change is 2 ppm per year by burning fossil fuels. So we are now 10,000 times more powerful than the natural forces that tend to cause CO2 to change on long time scales. So from now on, humans are in charge of the future changes of atmospheric composition, and we're going to determine the future climate changes. And this temperature curve for the last 65 million years, when you look at it carefully, you see in the last millions of years, there's a rapid oscillation of global temperature associated with the glacial to interglacial changes of climate, which you may be familiar with. 20,000 years ago, there was an ice sheet that covered Boston, it covered Canada, and some of the northern parts of the United States, and sea level was 110 meters, or about 350 feet actually, lower than it is now because of those large ice sheets. Those climate oscillations are associated with very minor perturbations of the Earth's orbit, which can cause the ice sheets. It will affect the distribution of sunlight, its seasonal distribution and geographical distribution on the Earth, and can cause ice sheets to grow or melt depending upon the eccentricity of the Earth's orbit and the slight tilt of the Earth's axis, which these parameters are perturbed by Jupiter and Saturn, which tug on the Earth's orbit and cause these small perturbations. But by means of slow feedback processes, this melting of ice will cause the surface to be slightly darker, so it absorbs more sunlight, and that makes it a little bit warmer. And as the ocean gets a little warmer, it releases CO2. So it turns out that these glacial to interglacial oscillations are entirely explained by these slow feedback processes in response to the small perturbations of the Earth's orbit. Those two feedback processes being the changes in the amount of CO2 and methane in the atmosphere, and also the changes in the surface reflectivity of the planet. But now, if I showed you the graph of the amount of carbon dioxide in the atmosphere, you would see that those oscillations from glacial to interglacial time have now been completely replaced by a rapid increase of CO2 and methane, which has taken the amount of these gases far outside the range that it has been in for millions of years. And the planet is beginning to respond to those changes in atmospheric composition. It takes it time to respond because of the inertia of the system, mainly caused by the ocean, which is 4 kilometers deep. It takes it a long time to warm up as the greenhouse gases increase the heating of the surface. They do this because they absorb heat radiation and therefore reduce the heat radiation to space the same way that a blanket keeps in your body heat when you put a blanket over your body. So the planet is beginning to warm. It's warmed by about 0.8 of a degree Celsius, about 1.5 degrees Fahrenheit in the last century, with most of that warming in the last 30 years. You don't notice much of an effect in your daily life because weather fluctuations are 10 or 20 or 30 degrees, while this warming is a couple of degrees Fahrenheit over land areas. But there are many things that we can see if we look around the planet. And for example, one of the graphs that I show is the mass of the Greenland and Antarctic ice sheets, which we began to measure with great precision about 7 or 8 years ago, with the launch of this amazing gravity satellite, which measures the Earth's gravitational field with such a high precision that you can determine changes in the mass of these ice sheets. And what we see is that at the beginning of this period, both Greenland was losing mass at a rate of about 150 cubic kilometers per year. Well, that's now increased to about 300 cubic kilometers per year. The rate is a bit slower in Antarctica, but it also has doubled over that time period. A few more doublings of that rate, and we will begin to have the effects that I talk about in Storms of My Grandchildren, all of the chaos that will occur once these ice sheets begin to disintegrate rapidly and cause the high-latitude oceans to be cooler. And as the low-latitude oceans continue to get warmer, we're going to get much stronger mid-latitude cyclonic storms. There are a number of other phenomena where we can see the ocean is becoming more acid, which is causing coral reefs to be under stress. Mountain glaciers are melting all around the world. Climatic zones are beginning to shift. The subtropics shift poleward as the planet gets warmer. And we can see that affecting the southwest United States, the Mediterranean region, on Australia, where it's becoming hotter and drier in these places with more forest fires. If we want to stabilize the climate, we will have to remove the planet's energy imbalance. One thing we can measure from the rate at which the ocean is increasing its heat content, based on very precise measurements of the ocean temperature, we can tell that the planet is out of energy balance by something like half a watt per meter squared, or perhaps 3/4 of a watt per meter squared. That is enough that it will cause much larger climate changes over the coming decades unless we can remove that energy imbalance. And the way that we would do that is to reduce the amount of these greenhouse gases in the atmosphere. To remove a half a watt of imbalance would require taking CO2 back to about 350 parts per million from the present 387 parts per million. But in fact, it's continuing to increase. But if we want to preserve creation, the planet on which civilization developed, we're going to have to do that. And what that means, if you look at how much carbon there is in the individual fossil fuels, oil, gas, and coal, you see that coal is by far the largest. It's been the biggest contributor to the CO2 increases that have occurred already, and it has by far the largest reservoirs. We're going to need to phase out coal emissions over the next couple of decades if we want to stabilize and reduce the amount of CO2 in the atmosphere. And we're going to have to prevent the use of unconventional fossil fuels like tar sands and tar shale, because they are the dirtiest fuels and they have a tremendous amount of carbon dioxide in them. But what is really happening in the U.S., we just signed an agreement with Canada for a pipeline, to build a pipeline from the tar sands in Canada to bring oil from these tar sands to the U.S. And oil shale is beginning to be developed in an early stage. And coal-fired power plants are continuing to be built. And these have lifetime of 50 or 75 years. So there's a huge gap between the rhetoric about climate change and reality. The rhetoric is that we have a planet in peril. But the reality is that we're continuing with basically business as usual. So it's a case where greenwash is winning. There's no politician who's been analogous to Winston Churchill to stand up and tell the people the truth and what is needed in order to deal with climate change. The Kyoto Protocol, for example, after it was agreed, prior to the Kyoto Protocol, carbon dioxide emissions were increasing 1.5% per year. With this cap-and-trade approach, where countries set targets and then they can have offsets so they don't really have to meet those targets, emissions actually increased to 3% per year after the Kyoto Protocol was agreed upon. The fundamental problem is that fossil fuels are the cheapest form of energy. And as long as that is true, we are going to continue to use them, and even more so. They're not really cheapest, but they are cheapest for people to use because they are subsidized by governments and they are not made to pay the price to society. They're not made to pay for the costs of the damage to human health that's caused by the mercury and the arsenic and the aerosols that come from burning fossil fuels, or the damage to the environment, or the damage that our children and grandchildren will realize as climate changes. So the solution needs to be a rising price on carbon. Unless we have that, we're not going to be able to solve the problem. And we shouldn't pretend that any goals for emissions reduction can solve the problem. A price is not sufficient by itself. You need regulations, for example, on vehicle efficiency and building standards. But you need the carbon price in order to enforce building standards, for example, and the operation of buildings. Unless the fuel is costly, it's simply many people simply ignore the impact of inefficient use of our facilities. And technology development is required, but again, you need a carbon price in order to incentivize that technology development. So my suggestion is that we need to put a simple carbon fee at the mine or the port of entry. At the coal mine or the wellhead or the port of entry where the fossil fuel comes into the country. And that price, that fee, needs to gradually rise. It would be collected from the fossil fuel company, and the total amount of money should be distributed to the public on a per capita basis. So every legal resident of the country would get an equal amount, distributed monthly electronically to their bank account or to their debit card if they don't have a bank account. And for example, by the time the carbon fee reaches the equivalent of $1 a gallon on gasoline, the collected money in the United States, given the amount of coal, oil, and gas that we used last year, would be $670 billion. If you divide that among the legal residents with half a share for each child, up to 2 children per family, it comes to $3,000 per person. So for a family with 2 or more children, it's $9,000 a year. Well, their energy prices are going to increase also. The 60% of the people using the least amount of carbon would actually get more back in the dividend than they get in increased energy prices. But the people who have 2 houses and big cars and fly around the world a lot would pay a lot more in their increased energy cost than they would get back in the dividend. But with that kind of a price signal, people would begin to take actions, because when they recognize that the carbon fee is going to increase over time, the next time they buy a vehicle, they'll get a more efficient one, and they will take the steps to reduce their emissions by insulating their home or getting more efficient appliances, and that way keep their increased energy cost less than the amount they get in the dividend. But what Congress was proposing is a cap-and-trade scheme, which is designed by and for big financial institutions. Morgan Chase, whatever their name is, and Goldman Sachs are the 2 biggest players in the planning to be in the trading game, in the carbon trading game. But there's no need and there's no value added by having that sort of scheme. What you need is a simple, honest price added on carbon with the funds distributed to the public. There's no need to give 1 dime to these financial institutions. And this can be implemented very promptly. British Columbia did something very similar to this. They called it a tax, carbon tax. They passed a law with a carbon tax collected from the fossil fuel companies, and with the money then used to reduce payroll taxes. And that is actually very popular with the public. When the opposition party made it the major issue in the election, they ended up losing the election, and now they've adopted it as part of their platform. So this kind of a simple, honest approach can actually work, and it can be brought into being very promptly. So what this fee and dividend approach addresses is, first of all, the economy, because it stimulates the economy. It puts money in the public's hand, a lot of money. And secondly, it addresses the energy problem, our fossil fuel addiction. It's the fastest route to a clean energy future. And third, it addresses the climate problem. And it's the only internationally viable approach, because there's zero chance that China will agree to a cap on its economy, or India. There's no chance that they will do that. But they recognize they don't want to have a fossil fuel addiction like the United States developed. So they actually are ready to negotiate that kind of approach, where they would have an internal price on carbon emissions, which they collect themselves and they use how they decide to use it. But that's the only viable way that I can see for having an agreement between China and the United States, and that's the essential requirement in order to solve the climate problem, is an agreement between the U.S. and China. And if we had this gradually rising price on carbon, that would result in most coal and unconventional fossil fuels being left in the ground. And that is what we have to do in order to solve the problem. Now, I also have had some charts showing, despite the fact that the science has become so much clearer over the last few years, and the fact that we are very near tipping points that are potentially have disastrous consequences on the timescale of this century, during the lives of our children and grandchildren. But despite that fact, the public is less informed and less convinced about this than ever. And it has a lot to do with the people who would prefer not to change business as usual, and they've been very effective at misinforming the public, and the scientists are very ineffective at combating that propaganda. But I was going to show charts about, and another thing that affected the perception of people is cold weather in December, which was an unusually cold month. But I could show you the map of the global temperature. In fact, although the mid-latitudes in the United States and Eurasia were 7 or 8 degrees Celsius below normal, other latitudes were that much above normal, and it was actually globally averaged a very warm month. It's just that weather fluctuations are large, and you often get cold weather in the winter, and it doesn't indicate anything about the reality of the global warming, which is proven in many different ways. But the main point that I want to make is the people need to try to put pressure on the political system so that the government would take an honest approach in which they address the fundamental problem, which is the fact that as long as fossil fuels are the cheapest source of energy, we're going to just keep using them more and more. But there are ways that we could gradually increase their price in a way that does not have a negative effect on the public. It's not even appropriate to call it a tax. You should call it a fee and a dividend. You give back every cent that you collect from the fossil fuel companies, you give to the public. And that will stimulate the economy. It will phase out our addiction to fossil fuels, and it will solve the climate problem. So it's not painful. It does require people to pay more attention to their energy use, and especially their fossil fuel use, but it's something that makes all kinds of sense. And if we have any interest in preserving a climate preserving a future for young people, we had better do this. Thanks.
You are joining us at Cambridge Forum to listen to James Hansen. The floor is open to the public to come and speak at the mic.
Yes, Dr. Hansen. My name's Daphne Abiel. I'm a reporter and freelance writer. I'm going to ask you a political question. Of course, we're all aware of the Supreme Court decision that came down a couple of days ago, giving corporations the power to back their interests with cash. What is your relationship now with the Obama administration? Do you have a good conduit to them? Are they listening to you? I mean, I saw the edited and censored texts of your articles during the Bush administration. Has your relationship with the administration, with the president, has that improved?
The thing that you point out about the role of special interests in the government, that is the fundamental problem. We have 2,400 registered energy lobbyists in Washington, which is 4 times greater than the number of Congress people. And there are many unregistered lobbyists, and it's just the way our system has developed, and it's not, a democracy can't really function properly with money. It's more a case of $1, 1 vote than one person, 1 vote, the way it seems to work now. I point out, for example, that in 2008, Richard Gephardt, after retiring from the House Democratic leadership, got $120,000 per quarter from Peabody Coal, which is almost $500,000 a year. So that's a problem that we have to, that's why the public has got to understand this situation and demand an approach which actually is in their interests, not in the interest of the special interests. I think and if you look at it, this is really a difficult situation, because if you look at the current administration, as I say, they say the right words. We have a planet in peril, and yet their proposed solution, cap and trade, is a non-solution. You can easily demonstrate that it's a non-solution. We have the example, and there's no way that it can possibly be made global. As I mentioned, China and India are not going to accept a cap. So, well, I think now is our chance, actually, because of the fact that Copenhagen didn't completely fail. The U.S. and China talked to each other and did not walk away. And it is essential that the agreement will be between the United States and China. And they did not adopt the cap-and-trade scheme. And furthermore, Congress now realizes that they can't pass this cap-and-trade scheme. I think, and they're beginning to move in the right direction. They're now talking about the possibility of a cap and dividend, where they've picked up on this idea of a dividend, that the money that would be collected in selling the rights to pollute would be distributed, at least part of it, to the public. But that's not sufficient. You also must have a simple fee across oil, gas, and coal at the mine or port of entry. You can't do it with these schemes which allows these deals in Congress, all sorts of, and the offsets. What they've talked about in the Waxman-Markey bill and in the Kerry-Boxer bill allowed offsets. So instead of really reducing the carbon emissions, you would presumably preserve a forest someplace. Those offsets can be shown to be ineffectual. You actually have to reduce the carbon emissions. So now, I have sent a letter. I know, and John Kerry has now said that they, need to try different approaches. So I think there's a chance that if this issue can be articulated well enough, and if the public has to begin to understand a little bit about what is being talked about there, what is the difference between cap and trade and fee and dividend, because their interests are very much dependent on what is actually the approach that is used. And it just makes so much common sense for the economy, for the energy problem, and for the climate problem to have a very simple, honest approach. You don't need a 2,000-page bill full of favors to all kinds of special interests. That's what the Waxman-Markey bill is. But these people, Markey, as you know, is one of the friends of the environment. John Kerry is, Barbara Boxer is, and yet they feel that the way Washington works, we've got to make these deals. We've got to make a deal with the coal state senators, and we have to make a deal with these other guys and give them something. But it's all screwing the public. If you need a simple, honest approach, and that has got to be understood, and if we don't do that, we're not going to solve the problem. So now the failure to move forward, to the fact that they realize they can't go ahead with the scheme they were thinking of, should cause people to now rethink this and do it in a way that would work for the benefit of our children and grandchildren and all the other species on the planet, and actually for the benefit of our economy. We need a way to move to the clean energy future. And the way you do that is to have the incentive that will cause the entrepreneurs to develop the low-carbon technologies. And the simple way to do that is with a price on carbon.
If nothing at all is done, what are the chances of reaching the tipping point within the next 10 years? In other words, how firm is the timeline on the tipping point for irreversible global warming? And I'd also like your opinion on whether you think there's any validity to the theory that sunspot variations is causing the fluctuation in temperature, not CO2.
Yeah, let me start with the last part of your question about what is the role of sunspots or solar variability in causing climate variability. The sun is variable. And we've been measuring the sun very precisely since the late 1970s. And there is a simple, clear correlation between the amount of energy that the Earth is getting from the sun and this changes in the sunspot cycle. It's about 1/10, the amount of energy that we receive from the sun varies by about 1/10 of 1% with that solar cycle. And it may be that on century time scales that the variations are bigger than that. And the Little Ice Age, when the northern hemisphere, at least parts of it, were significantly colder than they have been in the last century, is probably related, at least in part, to the variations of the sun's irradiance. However, we can now compare very precisely the climate forcing due to the solar variations and the climate forcing due to the carbon dioxide variations. And the growth in CO2 in 6 to 8 years is enough to offset this 1/10 of 1% type variation of the sun. So it's clear that humans now are causing a forcing that exceeds that solar variability. The solar variability still has an effect, but it's a modulation of a steady increase in the greenhouse forcing. And if you look at the temperature response, it's consistent with that. So the sun is a real forcing, but it's now much smaller than the human-made climate forcing. Now, tipping points is a difficult problem because it refers to the nonlinear response of the system. When do you get to the point where you suddenly get collapse? For example, one very important tipping point is the time when the collapse of the ice sheet, either Greenland or West Antarctica, and West Antarctica is the more vulnerable because it's sitting on bedrock below sea level. So it can collapse and go into the ocean much quicker. It's very hard to say when we've passed that tipping point because it is the most important process is the heating of the ocean. As the ocean warms, it's melting the ice shelves, which are the tongues of ice that come out from the ice sheet into the ocean. And those tongues of ice are buttressing the ice sheet. They're slowing down the streams of icebergs from the ice sheet. And what we see, the reason on my one graph, which I didn't show you, but the fact that Greenland has now started shedding icebergs at a rate of 300 cubic kilometers per year is because the ice shelves on some of those ice streams have been melting. I think that if we restore the planet's energy balance, reducing CO2 back below 350 ppm, that we have a good chance of avoiding passing the tipping points. We may be able to be in this dangerous zone for a few decades before ice sheets collapse, but in order to get back to 350 ppm, we have to start very soon in actually reducing our emissions, or it's not practical to get back to 350 in less than a couple of centuries. And we can't remain with a planetary energy imbalance for a couple of centuries without passing those tipping points. So unfortunately, I can't give you a precise answer. And there are different tipping points. The other one, which is irreversible, the ice sheet thing is irreversible on timescales of tens of thousands of years because that's how long it takes to build up a new ice sheet from snowfall piling up. But the other one that I worry about that's irreversible is extermination of species. We're putting more and more pressure on different species as the temperature lines move up the mountains and move poleward. Again, it's a tipping point situation because if some species go extinct, that affects other species because of the interdependency among different species, and you can cause ecosystems to collapse. But again, it's hard to put a date on when you've passed tipping points, but I've said a few years ago that I think we have to get on a very different path within a decade, and we've used up almost half of that decade without changing our path.
Dr. Hansen, thank you for your time. My name is Jeff Chapin. Thanks in part to the alarm bell that you've sounded for our country and our world. I started a company that tries to address this at the residential level. My question for you is, I love the solution that you're proposing. It seems simple and brings benefits to consumers and the citizens up front, which we know is a key policy initiative. You've got to have the benefits really precede the costs. So my question to you is there a way we can make that more of a forward benefit, bring it more forward than the costs? What can companies like ours and concerned citizens do to advance this solution? And secondly, what would the critics who have been effective so far in casting doubt on the science, what would they say to that, and how would they distort it so that we can think ahead and try and counteract those arguments as well?
I think that many businesses actually would support this, because what they have said is that they want to know what the policies are going to be as a function of time so they can make their investments appropriately. And the cap-and-trade system, for example, doesn't give them that confidence, because they've tried to such a system in Europe, and the prices will collapse. It's very volatile price signal from a cap system. But if you specify a linearly or a steadily increasing change in this carbon price, that gives businesses a signal that allows them to make their investment decisions. And even ExxonMobil, which you normally think of as being very resistant to making changes, actually said they would prefer such an approach. But as far as moving it forward, I think that you do want to stimulate the economy, and this is actually a rapid way of doing it, because you can. As I mentioned, it was implemented within months in British Columbia when they decided to do it. You could just declare that you're going to move the dividend up faster, because you do know the rate at which you're going to collect. We do know quite accurately the rate at which we're burning fossil fuels. So there'd be nothing to prevent that. But I think that if you want to avoid having a bigger deficit, a government deficit, you'd just say, let's make it 100%. And I say that the motto should be 100% dividend or fight. Don't let Congress loves to decide how to spend the money, but I think the public has to insist it's not the most efficient way to spend the money. Let the marketplace choose as to what are the technologies that are most effective in reducing emissions.
Hi, I'm Geneva Boyer, and I was wondering, you're talking about putting pressure on the political systems and stuff. So obviously we can write letters, make phone calls. What would you feel the most direct way for the average person, like sitting here, to go out and further this sort of agenda?
Yeah, I think that the key Congress people, and you have some of them here in this state, need to understand what you think about this. And you can do that by calling them or going to their office, or the form letters, I think, are just not very effective. But the individuals who actually make an attempt to contact senators and representatives can have an impact. So that's what I would encourage you to try to do.
Hi, I want to thank you for all the great work that you've been doing for quite a while now to raise awareness and just keeping at it. It's great. My question or my thought is on your plan for imposing a fee and then the dividend. That seems like it needs to be a kind of a global agreement, a multinational agreement, because I could see businesses saying, well, it's going to raise the price of the goods we produce and then we won't be able to export anymore, and it will give other countries an unfair advantage for importing. So I assume that's your plan, is that it needs to be
Yeah, in fact, that's the reason that I think this can work, because you do have to get an agreement between the United States and China. They're the two nations that are going to be competing for the 21st century. And it's, I think, the only way. I haven't spoken with Chinese leaders, but I've spoken with Chinese scientists and people working for their organizations, their non-governmental organizations, and they actually think that the Chinese government is ready to talk about that kind of an approach because it's in their best interest. They need to avoid fossil fuel addiction. And then, once those two major players agree, then of course Europe and Japan, there's no reason they wouldn't go along with this. The countries that don't want to have a carbon fee, the WTO, World Trade Organization, already has rules that would allow you to put an import duty on products from those countries that don't have the fee, the carbon fee. And that would be a very strong incentive for other countries to have a fee, because they would rather collect the money themselves rather than have the importing countries collect the money. So it is specifically designed with that idea in mind, that unless you can have an approach that's going to go global, it's not going to work. That's why Kyoto didn't work. You had some countries agree to something, but then the products just got made elsewhere and then shipped back to the developed countries. So the total emissions actually increased. You have to have a way to make it global.
Susan Shamel, thank you, Dr. Hansen. Geneva kind of asked my question. I was wondering what I, as an individual climate activist, should do. So let me expand it further. It seems like all the groups are kind of floundering now about what to do. 350 is thinking for a month. Greenpeace just had a retreat, and they're thinking One Sky just had a conference call. And it seems like everybody's floundering. What do we do now? We've tried this, we've tried this, we've tried that. And it seems like one thing my husband and I think is that all the climate groups really need to come together and, do one big thing. I mean, One Sky will say, send a Valentine to your congressman, and I don't think that's going to do any good. So my question to you is, what should we do collectively?
I think that until environmental groups recognize the fundamental truth that as long as fossil fuels are the cheapest energy, none of this stuff is going to work. And these tricks, a cap-and-trade trick, is you've got to recognize that as being ineffectual. Once you admit that you only way to phase in renewables and efficiency and forms of energy that don't produce carbon is to make them economically competitive by raising the price. And all we're doing in so doing that is making the fossil fuels pay for the damage that they cause. Instead of subsidizing them, make them pay for the damage that they cause. And it just makes, from the public's perspective, it just makes all kinds of sense. It's only some of the fossil fuel industry and others who've been very effective at preventing that kind of change. But if the public understands this and understands that it's not a climate question, it's an energy question, and it's an economic stimulus for the country, which would be very beneficial, and it would help the people who have been, I need to have a different word, but have been cheated in the past few decades. The middle class and the people less able to afford things would benefit from this, because they would be willing to pay attention to their carbon footprint and their energy use and actually come out ahead in this process. Thanks.
My question is, what's the most effective way to dispel the myth that scientists have incentive for making this stuff up to scare us?
Yeah, I sure wish I had a good answer to that. I have 5 sisters in the Midwest, 1 brother, and they tell me that now a good fraction of the people think this whole thing is a hoax. It's been very effective propaganda that it's hard to say to what degree this is orchestrated. It seems to be more just a combination of all the contrarians realizing that that they can make the public very confused and skeptical about the science. And I'm, spend half my time now responding to Freedom of Information requests. They've requested every email that I've ever written and all my correspondence and everything. They're looking for any sentence or phrase or anything they can use that will make it sound like maybe we're trying to get a certain answer from our science, which is, and scientists are just not very good at defending themselves in this kind of political, I don't know what to call it, but it's a street fighting, which is, scientists don't know how to deal with that. But still, so we have to try to make clear the science, and I think that most of the public still respects scientists. It certainly has taken a hit in the last year or so, and I don't know. I think, it seems to me that the National Academy of Sciences should step in and do a investigation or study if they have to, but just make clear that, what the actual situation is, because the public is being effectively lobbied or swift-boated. The scientists are being swift-boated by people who either have a special interest or they're genuinely, there are a small percentage of people who just don't believe this, and they're very effective in convincing the public that it's a 50-50 proposition, even though the science has become in reality very clear. And I think the National Academy of Sciences could and should make that clear.
Hello, Dr. Hansen. My name is Robbie. I'm a sophomore at Cambridge Ridgeland High School. And my question for you is, how did you become first involved with climatology, and what brought you to where you are today?
Yeah, well, I was very lucky when I went to school, and what was easier for me was math and physics. But I just happened to be at a school, the University of Iowa, where the physics department was headed by James Van Allen, who's a famous scientist who discovered the radiation belts around the Earth. And I got drawn into his program and was lucky to have him notice me and become the advisor for my thesis. So I worked on planetary atmospheres. He pointed out new data on Venus, radio emissions from Venus, which suggested that either it's very hot or else it had a charged ionosphere. And so he suggested that I work on that for my PhD thesis, and I did that. And then, after leaving the university of going to NASA, I proposed an experiment to go to Venus to study the clouds of Venus. But while it took 5 years to build that experiment, and while it was being built, I was asked by a postdoc, actually from Harvard, to help him with calculations of the greenhouse effect of nitrous oxide and methane, trace gases that people hadn't looked at yet. And we wrote a paper together, realizing that these gases were effective greenhouse gases, and they were increasing. So I realized that our own planet was changing before our eyes, and is much more interesting and socially important than Venus. So I resigned as the principal investigator on the Venus experiment, and a friend of mine took that over. And ever since then, I've been working on trying to understand the climate. And I prefer to just do the science. It wasn't until, I had testified to Congress in the 1980s, and then I decided to go back to the laboratory and just work on the science, because I don't particularly like public speaking, and it's not my strength. But after I had grandchildren, I decided and realized that we just keep going on this path, even though it's clear where it's headed. And it's a path that we could get off of to our benefit, but we're not doing it. So I decided 5 years ago I didn't want my grandchildren to say that Opa understood what was happening, but he didn't make it clear. So now I've started to try to make it clear, and that's why I wrote the book.
Good evening. I'm Bill Ackerley from Cambridge. I know you partly answered this, but I just came back from Colorado and talked to a good friend of mine who works in environmental issues, but he rails against scientists. They're just in it for money. He rails against Al Gore. He just wrote that book to make money. Anything who's elite, like scientists, you can't trust them. And to get that message, he's a Republican, and Colorado, as you know, is the big coal-producing state. So, I don't know what he's doing. But anyway, it's hard to, you say the public, but there's a large part of this public who doesn't believe it.
Yeah.
It's amazing. Anyway, thanks for coming.
It's unfortunately, you're right, but if you look at scientific career is not a lucrative career. I drive a 1992 Volvo because it just keeps running. It's got 200,000 miles, but it keeps going. We have a big PR problem. And I still think that scientists, in fact, the polls still show that although the percentage of people who trust scientists has declined in the last year or so, it's still quite high compared to politicians, compared to a number of other categories. So I think there's still hope, but we do have to somehow do a better job of communicating with the public.
Dr. Hansen, thank you for coming to Cambridge. It's a real honor to see you speak. Following your work for 20 years. I've got two questions. And by the way, if your car has over 200,000 miles on it, based on the election we had here, you could run for the United States Senate. don't know if you get that joke, but people here do. One of my problems is the Senate. I like your approach, but under either your approach or cap and trade, I don't see how we get to 60 votes because there's so many senators from states with fossil fuel interests. We just elected a senator who says he doesn't know if he believes that climate change is man-made or not, which is a real shame. You know, Massachusetts was a leader in this subject. I don't know what the two senators from Maine will do. I just don't see how we get to the 60 votes under either approach. That's why I've been telling friends to urge their senators to repeal the filibuster rule. I don't know if there's any spine to do that. That's one question. Second question is, I'm a little skeptical that just increasing the cost of fossil fuels will spur the alternative energy industry quickly enough. And that I think the federal government still needs to put billions of dollars in. I know Senator Clinton and Senator Obama, when they campaigned, talked about putting $15 billion a year in. Obama had put that in his budget. And actually, I think he had something similar in his budget proposal. Under the cap and trade, most of the money would have gone back to the taxpayers. $15 billion would have gone to renewable energy. I wonder if you could answer those two questions.
Yeah, now the first one again was...
Well, how do we get to the 60 votes in the Senate?
Oh, okay.
Because when I look at the states...
Okay,
and
the
our own
way
state now,
I think, yeah, those are two very good questions. The first one is, I think we have to emphasize that it's not a climate matter. It's first of all the stimulating the economy and getting some money in the hands of the people who need it most. And secondly, it's the fossil fuel addiction. Now, even both parties agree we have a fossil fuel addiction problem, and it's causing us to have to protect supply lines around the world. It doesn't, we need to fix that energy problem. And climate is only third on that list. So even if you don't believe the climate story, you can still address this. And I think the business community agrees that they would like a well-defined, honest approach. So I think it does have a chance if we just have proper discussions of this, and people have to go back and rethink the tricks they were trying to use with bribing different senators with special favors for their state or whatever. That's not the way to do it. Now, the second, what was the second part of your question? I've got a very short memory, I guess. I'm 68 years old.
That's okay. Yeah, my memory's going too. I'm sorry, the other point was that I think we need to put massive amounts of money into renewables
Oh,
right
yeah.
now.
You're absolutely right. Now, I did not mean to imply that the carbon price does everything by itself. It's just a floor. The other things don't work without that floor. Without that basic incentive, for example, the building standards, the people responsible for the government and local governments will say, you know, you can have building inspectors, you try to have standards, but then you can't be there all the time, and then once they're operating the building, that's, you know, they don't have to, if energy is cheap, they don't bother to really meet the standards. So you need that price signal in order to provide this extra push, but it's not enough by itself. You've got to have regulations for vehicle efficiency, building standards, but also things like utilities. You need to change the rules so that they make more money if they make things more efficient rather than selling more energy. So yeah, there are other actions besides the price, but it's the fundamental requirement underneath it all, I think.
Good evening, Dr. Hansen. I'm Laurie Lashon from Massachusetts Green Jobs Coalition, and it's great to see you again. I am always in awe of your scientific genius, but I was so inspired by you sleeping out on the Boston Common with the leadership campaign just a few days after your surgery. Your switch from being a scientist only to an activist is just so commendable. Really, it's what we need, and I really appreciate it. So I have a lot of scientific questions, but I'm going to focus on the political ones. And I'm wondering, with following the other comments that have been made and the obstacle of the 60 votes in Congress, what about a ballot initiative as an alternative? And I've got a couple of sub-questions to that, because you hold up British Columbia as a model when this is a global construction around this fee and dividend. And I'm wondering how British Columbia did that in isolation. And if they did it in isolation, could a city do it in isolation, Cambridge maybe, or a state, Massachusetts maybe? And could that be carried out to other states? And then as another part, I totally see Congressman Tierney as an ally in this. I found him to be very favorable. But I wonder who else besides Tierney, Markey, Carey, Capuano, I would hope, who else can we identify as really strong allies that would speak out on this? And then the final part of the question is, what was Obama thinking when he advocated for, well, maybe you will tell me this, because I think maybe you are also in favor of nuclear power and offshore drilling. How does that work?
Yeah, I think that there's a great potential for a local or state or multi-state initiative. You can't go too far with it, because if only one state puts a carbon price, it does incentivize their local industry, and it will end up giving them a head start. So it makes sense. So I think that should be encouraged. I mean, Massachusetts is a state that should really think about a fee and dividend approach, in my opinion. That was one of the reasons I came to sleep out on the Commons, was because I wanted the students to advocate such a action.
I knew that. I set you up for that.
But what I found was, and then I went with some of the students and spoke with some of the politicians, and unfortunately they had actually been out in front a year or two earlier, had begun to push for cap and trade, which, as I've argued, is a non-solution. And to get them reconfigured into an approach that actually would work is not so easy once they've taken a step down the wrong direction. And that's why I said I hope Copenhagen doesn't do anything, because if they had started down that cap and trade route, it would be 10 years or probably 15 or more years before we realized, hey, this isn't working, we've got to try something very different. So yeah, I think you should try to push local and state and even regional, multi-state. But I think, given the resetting in Washington, that there's actually a chance to get them to understand it there. If we would just get a few key Congress people to begin to understand this and advocate it. Now, nuclear power, the second part of your question, is one which is very touchy in some states, like California, and maybe with some people here. And I was always very skeptical about nuclear power because it has such obvious problems. The nuclear waste problem, the fact that it's expensive, the fact that there's the possibility of an accident, and the fact that you don't want the material to possibly be acquired by people who would use it against the public. But after I began to look at it as possibly the lesser of two evils once I realized what's happening with coal. If you look at coal, there are more than 100,000 people per year who die from air pollution, air and water pollution. Actually, it's much more than that, but a fraction that we can certainly ascribe to coal is at least that large, and probably a lot larger. And yet we continue to, if there were 100,000 people killed by a nuclear accident, we would never build another nuclear power plant again. But we continue to, just because coal is such common stuff, even though it's incredibly dirty and has arsenic and mercury, and we can't eat as many fish as we would like because they're contaminated with mercury, we just ignore that problem. Well, what I learned was that when you actually look at the safety record of the nuclear industry, even with the current generation of nuclear power plants, which is not ideal, it does involve human factors. If there's a problem, you've got to turn the thing off. But the coming generations, the third generation, which is the kind they want to build now and they're ready to build, and they're starting to do it in China and some other places, is much safer than the second generation, because it will automatically shut down if there's an anomaly. So the accident problem is reduced. But nevertheless, I was still skeptical about nuclear because, first of all, the amount of uranium is finite. Isn't it going to run out in a century or so? Well, what I learned was that the fourth generation nuclear power, the fast nuclear reactors, which allow the neutrons to move faster so that they can burn all of the nuclear fuel, have some potential for solving the worst problems about nuclear energy. The present generation, and even the third generation, these light water reactors, burn less than 1% of the energy in the uranium. The rest remains in a waste pile, which has a half-life of 10 to 100,000 years, a tremendous problem, expensive problem to deal with, that waste. But fourth generation nuclear power burns more than 99% of the energy in the nuclear fuel, and it leaves a waste product which is much smaller in volume and has a half-life of less than a century. So you're talking about needing to deal with it for a couple of centuries instead of tens of thousands of years. And it means that, and those fourth generation nuclear power plants can actually burn nuclear waste. So that is a more likely solution to solving our waste problem than the Yucca Mountain, which seems to be off the table anyhow. So, and I think, and the unfortunate thing is that the United States had by far the best expertise in this field. And in 1994, Argonne National Laboratory was ready to build a demonstration fourth generation nuclear plant, but the people who are against nuclear power got so worried about this because that meant there is no nuclear fuel supply problem any longer. It can last, including the fuel that's in the ocean, which Japanese scientists are already beginning to sieve out of the ocean, there's enough fuel to last for the lifetime of the Earth. So they convinced the Clinton-Gore administration to cancel the R&D program in fourth generation nuclear power. But in that, with the idea that they want to eliminate nuclear power from the Earth. But the problem is that there are half a dozen other countries which are already working in that technology. We can't eliminate it by stopping it in the United States. And it would be much smarter for us to be on top of the technology, because you want it to be as safe as possible and as resistant to proliferation as possible. And the best way is for the U.S. to exercise leadership rather than pretending that we can eliminate nuclear from the planet, because I just don't think we can do that. I think we're giving up the potential for an energy source that has no negligible carbon footprint. And I don't see how India and China can get their electricity without nuclear power or coal. The only way they can eliminate coal is with nuclear power. That's the conclusion. I've looked at this pretty hard over the last couple of years, and I think that we should be open-minded about developing safe nuclear power. But that's, I know not everybody agrees with that.
Thank you, Dr. Hansen. My name is Marty Driggs. Let me preface this by saying that as a climate justice activist of several years, I believe with every fiber of my being that we have the capacity as a human family to solve this problem. That being said, in your opinion as a climate scientist, at what point in the destabilization of our Earth's life support system do we realize that our efforts have not been enough, that relying on legislative efforts, on appealing to power structures that exist that got us here in the first place, on appealing them to solve that same problem, at what point, and I know we don't know when that tipping point is in time, but will it be when Greenland ice sheet disappears? When is it that we can shout, and many of us already are, we can take a nod from the two people that are in a tree right now down in West Virginia stopping blasting on Coal River Mountain. But when will it be time for us to realize our potential as a human family to do this?
The great thing is there are a small number of people, as you point out, who realize what we're doing, how we are likely causing a problem for young people and future generations, which, when they look back at us, will not do it with favor. The problem is caused by the inertia in the system, which causes the early effects to be small, and yet you're building up the inevitability of larger effects later. Now, it seems that the public and politicians are not able to react until they actually see something. So the question is, does that, and we are, it may be, this curve that I have for how the ice sheet loss was going like this, and now it's going like this, and if that falls off that cliff, well, then the science will become so overwhelming and that the world will realize, but then it's really too late. So it's my best estimate is that we have to get on a different path within the next several years, or else we are going to guarantee that we pass some of those tipping points. We may not pass there's one of them, the methane hydrates. That's the frozen methane, which exists in two places. One is on the continents in Siberia and Canada, in the tundra. As the tundra is beginning to melt, it's releasing some methane. There's also much more frozen methane in the continental shelves under the shallow ocean waters off the north coast of Canada and Siberia. That tipping point is probably further away, but that one we don't understand very well. We see that already the tundra is starting to emit some of this methane. I think that that's one that we can avoid if we get on a different path in the next several decades. But the ice sheet one, I'm afraid we're getting very close because the ocean is getting warmer and warmer, and that's going to melt ice shelves, and we can't suddenly cause the ocean to cool off. That will take, in order for the ocean to begin to cool off, you would have to remove this energy imbalance, which is half a watt to 3/4 of a watt, and that requires you to get CO2 back to 350, and you just can't do that like that. It'll take decades, so we have a problem. I wish I knew the answer to your question.
Hello, my name is Arthur Moore. I am a sophomore from the Cambridge French and Latin School, and I was curious, you said, you were talking about the carbon tax in British Columbia, and do you think that tax would be more efficient if all the money from it was put into creating clean energy?
You know, we have substantial budgets already in Energy Department, and I think that in order to stimulate the economy and to give the people the ability to deal with the higher energy prices, that we should give the money that's collected in this, I prefer to call it a fee, because it's not really a tax if you're giving the money back to the public. I think it should go back to the public, and I'd rather not have the government trying to decide which technologies are the most effective. It's better to let the private enterprise, once they know that carbon fee is going to go up, they're going to be doing all kinds of things, because everybody wants to be the next ExxonMobil. They want to have the kind of energy which people will buy. So I don't see, I mean, there are certain things where you do have to have the government involved, but we already have pretty big budgets for Department of Energy.
And also just a last question. Do you think that the tax should be increased depending on how much the use or the substance hurts the environment? For example, you said coal was contributed the most amount of CO2.
Well, you should have a flat fee, so it depends on the amount of carbon. So coal would be taxed the most because it's got more carbon, and unconventional fossil fuels. But that's one reason why the fee and dividend is very important, because the public, once they see this dividend, they're not going to object at all to raising the rate. I think most of the public is not, and so we got to get that started, because then people will understand it if we can just get it started.
Okay, thank you.
Thanks.
Okay, the last person in line will be the last one we can accept the question from, but come forward quickly, and we got to, in effect, give Jim some time to sleep tonight.
Hi, I'm Tinsley, and I'm a sophomore at Cambridge French and Latin. And my question is, those of us who are younger are going to be living with global climate change as it worsens, and I was wondering if there was anything in particular we can do to better the situation for our future.
I'm sorry, I missed the middle part of your statement there. I couldn't quite understand.
Us who are younger are going to be living with global climate change as it worsens. And I was wondering if there was anything in particular we could do to better the future for us.
Yeah, well, see, I think that parents and older people, it's just their nature to want to do well for their children. They work their fannies off to give their children a chance. But so if they would understand what the implications are for young people like you, then so helping them understand that is perhaps the most effective thing you can do. Thanks.
Each one teach one, and reverse the age pyramid here. It's the children need to teach their parents.
Right.
Good evening, Dr. Hansen. I was wondering, you keep talking about like the bad effects of coal and how coal is such an evil fuel, as it were. And what are your opinions on clean coal? Do you think that that's like just a complete myth, or do you think that there's any value in that?
It's been used to allow the continued dominance of coal as the energy source. And I frankly don't think there is any such thing as clean coal, but it's very difficult to eliminate some, even if you could capture the CO2. The problem is that will double the price of the electricity from coal. And so the public will never allow you to change these existing dirty coal plants. It's too big a cost penalty. So they know that all they're doing is making some test plant or something, and they've been doing that for more than a decade. The entire Bush administration had this clean coal program. At the end of the administration, they canceled it because it was just a propaganda thing. But if you put a carbon price on, it will automatically make that choice. If clean coal could really work, that would be able to compete with the other sources. But in fact, it's just going to fall by the wayside once the carbon price starts to increase.
Hi, I'm Gwen Child, also from Cambridge Ringen Latin, and I just did a semester abroad where we ran our the vans and the boats off biodiesel, and I was wondering if biodiesel could be a possible alternate to fossil fuel that could significantly impact the amount of carbon emissions.
I think that biofuel, I think that we'll probably figure out alternative ways to power our vehicles. Maybe electric will be a good part of it. But biofuels may be useful for things like aircraft. There, the amount that we need is an order of magnitude less than what we need for vehicles. And I could see having enough area for getting that magnitude of biofuels without having an impact on crops, which are needed for food. And there are possibilities for biofuels. There are interesting ideas about algae and other ways of getting biofuel without taking crop area at all. And those might work out. And again, all those kind of things would be stimulated by a carbon price.
Okay, so I'll ask the question that I actually came up here before to ask, which is, to me, as an engineer, your scientific argument is, it makes so much sense, it's irrefutable, but I'm wondering, have you tried to directly engage these people that are spewing the incorrect information and, trying to have an actual conversation with them or a debate where I don't know how they can really argue against in a situation where they're put on the spot, I don't know.
Yeah, well, next week I'm going to North Carolina, University of North Carolina, and we'll talk with after my talk with the governor's principal person for energy and climate. And I got a letter from John Kerry asking me to come and talk with him, and I plan to do that. I'm going to call him first, though, to make sure he's open-minded, that he's not just trying to convince me to support cap and trade. But what's happened in the last week or so, it's clear that he is now open-minded. So. There's just, the problem is there are just 24 hours in a day, but this is the time that it's appropriate to try to speak to these kind of key political players, and to the extent that they will listen, I plan to try a few of them.
My name is Alan Fierce. I'm from Stowe, Mass. Dr. Hansen, I do want to thank you for all your work over the years. I did see you speak up in Lexington, and you did have your slides with you at that time, and they were great. So my first question is there some way we can get Dr. Hansen's slides that he had prepared for tonight posted somewhere online, either by the Cambridge Forum or, I know Dr. Hansen has his own website.
We already put them on a thumb drive, which you plan to put on your website, is that right?
Yes, check climate-research.tv.
And for those who don't know it, Dr. Hansen has a terrific website of his own. Maybe you can give us the URL, but people can subscribe and get occasional missives from Dr. Hansen, which are terrific and really keep us up to date.
Yeah, it's www.columbia.edu/, what's the wiggle called? Tilde, and then my initials, JEH1, numeral 1.
I think you can also just Google James Hansen, and it comes right up.
Yeah.
I have a couple of questions, though.
Quick question.
I've been writing questions down and crossing them off as they've been already asked and answered, but I do have a couple that are left. Let me see if I can, what are the ones that would be most important for the whole group. I know in the past you've talked about the El Nino and El Nina effect, and you didn't talk about that tonight, but as I understand it, we're at a point in time where there's now a shift from one to the other that may lead us into some very hot years in the near future. Can you comment on that?
Yeah, 2008 was the coolest year in the decade. And it was because of a strong La Nina, which is the cool phase of this oscillation in the equatorial Pacific. We've now moved into a moderate, not huge, not very strong, but into an El Nino, which is a warm phase. And it's likely, I would say, greater than 50% chance that 2010 will be the warmest year in the instrumental record, despite the fact that we're still just beginning to come out of a strong solar minimum. I mentioned in response to a different question that the sun's brightness does change, and we've been in the deepest, longest solar minimum for the last 3 or 4 years, which reduces the solar energy by about 0.1%. We're just going to start to come out of that this year. So the next few years are, someone asked about, well, maybe we'll start to see some climate effects that will convince the public. But still, weather fluctuations are going to remain larger than global warming. But you should be able, and in my most recent thing that I put on my website, I show that though the weather fluctuations are large, the probability of warmer than normal seasons has increased noticeably if you're willing to compare to the 1970s. And even the frequency of a daily record warm temperature now exceeds by a factor of 2 to 1 daily record cold temperatures. But it's still got to be a little stronger before people will really realize that, I think.
One more?
Very brief last question.
Well, I hope it's brief. We've been talking about cap and trade and the problems with it, but I don't know that we've talked about it in a very specific way. I do support the fee and dividend approach, and I've had various debates with my friends, some of whom are cap and trade supporters, and they would say back to me that the cap in the cap and trade actually sets a cap, whereas the fee and dividend approach does not. And they point out, for example, that utility companies, which have captive customers, will simply pay the fee and pass the cost on to their customers. And therefore, the amount of actual CO2 reduction that you get from a fee and dividend approach is very uncertain, complex, depends on a lot of factors. And then they would say also that, well, let me just stop there. And with respect to the cap and trade, I believe it's a problem is the verification. When you put the offsets in, it's really a disaster. There's an article in Harper's Magazine this month about that. But I haven't really heard you say why you believe that the cap and trade system is doomed to failure? Is it because of that verification problem? And
Well,
the
it's a
linkage, or-
combination of several things. It's not a real cap. As you know, the plan for the U.S. reducing 17%, almost all of that is offsets. The actual cap would probably reduce things only a few percent. And the problem also is it's designed so that special interests can get in there and get allowances or things. And the problem is if a utility ends up saying, well, we're going to have a blackout, then you will increase their cap because nobody's going to allow blackouts. But there have been, economists have done studies to show what is the effect of, say, the Larson bill, which has like a $15 per ton CO2 and then increasing $10 or $15 a year. And by 2020, it reduces emissions, U.S. emissions, a real 32%. So it's, and practically all economists, except perhaps Paul Krugman, who I've had some differences with, agree that it's much more efficient and you get a bigger reduction with what they call a carbon tax, but I call it a carbon fee. So the fundamental point is you need to well, maybe I'll leave it at that. Yeah, I need to write this story, the comparison of cap and trade and fee and dividend down, perhaps to make the story clearer, because it is complex, and the public does need to understand it to some degree. Otherwise, the fossil fuel industry and the special interests will continue to torque government policies to suit their needs rather than the public's.
Okay, please join me in thanking James Hansen.